And of course, OGFC mixes need a high asphalt content for wet road durability. But since we started doing this research in the early 2000s, the price of liquid asphalt has increased by approximately a factor of 4. So some agencies, we have the notion that we don't need anti-strips for these mixes because they have thick film coatings, but these mixes are regularly exposed to full depth flowing water. So if you ever had a need for an anti-strip, it's this type of mix, either hydrated lime or liquid anti-strip. So we like to use high microtexture aggregates because they provide us with good friction. Some of those aggregates can be absorptive. And if they are absorptive, then we have the possibility of having a lower effective binder content over long periods of time. So the mixes can possibly dry out on the mat after placement. And the bottom line to this list that I've made here is that we go through cycles where we think we have it all figured out. This really especially applies to open grade friction core surfaces, but we have one hard winter, and then that makes us realize, wow, we got a whole lot more to learn about this. We didn't really have it figured out. We just had some easy weather for 3, 4, 5 years, and we still have some things to learn about these mixes. So before I hand off to Jim, I kind of wanted to make a list of why we need this, kind of to follow up on the question of why. So if you're a contractor, you need to know because binder is so expensive in the mix, you need to know what your binder content is before you bid on the job, not after you bid on the job. And that, I think that's an important thing, because in many of our design processes, the agencies set the binder contents. You got to have a good verification process in place for construction acceptance. We have a gradation in these mixes that are open so that water can flow out of the pavement tire interface and then off onto the shoulder. We have a binder content that satisfies our short-term and our long-term needs. So in the short term, we don't want drain down. We can't have so much binder that it drains down. When we place this mix on the roadway, it's got to be stable, and the gradation has to be open. And we'll talk about that more here as the webinar progresses. So we need a healthy, effective binder content even after long-term absorption. Everything that we do really here at the track, you can summarize with this brief statement: safe and sustainable asphalt pavement at the lowest possible life cycle cost. And I think that certainly applies to OGFC. These are very, very, very safe mixes especially on our high-speed roadways, and we need to use them. And it's important that we find a way to get good life cycle performance out of them. So I'm going to stop my share here, I think, and I'm going to hand off to Jim.
Well, good morning. Hope everyone's doing well. It's one thing about open graded friction courses is if you've ever driven on a road that has them as opposed that doesn't have them, you'll see that a lot. I live in Florida and work out of Florida, and Florida uses OGFCs, pretty much on all their high-speed facilities. And you can really tell even a job under construction when you think, well, the open grade really doesn't help that much. But then you get to like an underlying structural layer that doesn't have it, and it's a tremendous difference between the two. So the development of this mix was really a big thing, I think, and it did a lot to improve safety. So I want to just tell you just a little teeny bit about some of the background of it. Is open graded friction courses were introduced to the US in the 1940s. I think they had been used like in Europe and in Japan prior they came here. And at first they were plant mix seal coats, were almost like, think of a surface sealing type of project where a chip seal, but they would pre-coat the aggregate and then they would use a paver, and it went down pretty good, but it really wasn't used all that much. And I think it got in a little bit of increased usage in the 50s. A big thing that changed, and this is something I never really learned about until late in my career, was in 1966, the federal government passed the Highway Safety Act, and that established all sorts of standards for the type of safety programs that we have today. And it didn't just affect roads, but I think that's where it became a requirement to put seatbelts in cars. But it was everything from guardrails to making sure you've got the right cross slope and super elevations, things like that. But it also established standards that told state agencies that they had to come up with skid prevention programs. And again, from my history with the Florida DOT, I know it was around the late 60s when they started experimenting with different friction course mixes and different aggregate types. A number of states started to use these open graded mixes. There wasn't a design procedure. So in 1974, the FHWA kind of developed something. It was pretty raw. It was a number of states used it. Unfortunately, there were problems. They had problems with raveling, stripping, drain down, short service life. I know in some cases, the open graded mixes, the aggregate skeleton would kind of collapse and they would have not only a loss of permeability, but they'd have rutting. So they stopped using them. They revised that design procedure in 1990 and they published it in its technical advisory. You can see the number. So that was out there for a while. One thing about an open graded mix, when you're doing a mix design, like everything else that we deal with in the asphalt world, there's this pendulum that we're dealing with. In an open graded mix, you want to make sure there's enough asphalt binder for good durability. So it's going to last longer. Okay, we want that. However, if you put too much binder, you're going to have drain down problems, which would be a construction thing. You'll have fat spots in the pavement. You potentially have bleeding, which creates another safety problem. And you also have a loss of permeability. Florida, back in the early 90s, started using ground tire rubber in their open graded mixes. And we found we could keep increasing the amount of binder in the mix and we didn't have a drain down problem. It was great. Unfortunately, we realized when we would pave these projects that there was hardly any surface texture left. We had filled it up with too much binder. So again, just like everything we do in the asphalt world, where you add more binder, you get more rutting, you take binder out, you get more cracking. Same thing applies to open graded mixes. So getting back to that 1990 FHWA design procedure, it's still out there and it's a little bit primitive. They determine the surface capacity of the aggregate by soaking it in lubricating oil, and they take some measurements. They select a gradation, select an optimum mixing temperature. They use the pie plate method, which are still used by several states today. Pie plate would set the mixing temperature. And then they would evaluate the moisture susceptibility by slightly different tests than what we do today. So the world was a little bit different back then. And really there have been a lot of changes that have occurred, not just in open graded mixes, but if you think about how we were doing asphalt back in the 70s and the 80s and compare it today, it's entirely different. Materials now, we're using polymers. A lot of states use asphalt rubber. We've got stabilizing fibers that we're putting in mixes, and they can be mineral, cellulose, or synthetic. There's better liquid anti-stripping additives that really didn't exist, back in the 70s and 80s and even the 90s. I think the use of hydrated lime, it's been around for quite some time, but it's something that has you've seen it evolve into the use of open graded mixes more so than you saw before. Also, there have been changes in gradations. I think at first, a lot of states used 9.5 millimeter mixes, and then they switched to 12.5. Now there might be kind of a push to go back to the 9.5s. As far as design methodologies, now rather than looking just at like the absorptivity of the aggregate based on a motor oil, there's more of a focus on determining the volumetrics and the durability of these, and typically what they use the Cantabro test. But there are still remnants of the FHWA procedure around. And again, it's kind of an evolving methodology. These are the current open graded design procedures that are kind of out there right now that are relevant. I'm not showing the FHWA design procedure, but ASTM, I think, I can't read the number, but it's something like D7064. AASHTO has PP77. The NAPA document that goes through a design process. That's sort of interesting because that was originally written by Ken Kendall, who was an engineer here at NCAT. And he was the one, he's kind of the father of the current design methodology that we're all kind of, using some parts of today. And then most recently, there was another report that was done as part of an NCHRP project that really looked at what's the best way to design and maintain porous friction courses or open graded friction courses. So again, these are those same design procedures that we discussed previously. The NCHRP research report 877, that was from project 1-55, and I think Dr. Namtron from NCAT was the PI on that particular project. So again, NCAT has a lot of experience dealing with open graded mixes, and a lot of states have a lot of research on open graded mixes. And it's because open graded mixes, as good as they do for safety, they can always be really a challenge when it comes to performance. So in the basic recommended mix design methodology that most design processes follow, it really boils down to 4 steps. You select the materials, determine the gradation of the aggregate blend that you're going to do, determine the optimum binder content, and then look at, it will evaluate moisture susceptibility. So again, how this works, particularly design methodology, is it's in a way, it's similar to designing an SMA mixture. You've got to run some tests to make sure that you've got good stone-on-stone contact, which will hopefully prevent any type of rutting in that particular layer. So you determine what aggregates and binder you're going to use, determine the gradation of each component. On the +4 material, you got to determine the bulk specific gravity of the aggregate, as well as the dry rotted unit weight. So these are some tests that aren't typically done in like a conventional super pave design, but it is done for SMA mixes. These are some general design ranges. You can kind of read the numbers yourself. You see, most of them are focused on being a 12.5 millimeter nominal maximum aggregate size. And one of the things on that NCHRP project that was done is what they found was, in terms of long-term permeability and even durability, they probably got better performance out of the 9.5 millimeter mixes. But again, it's kind of a trade-off on different things. And we'll talk about that a little bit more later. So the second step is come up with a design blend, and depending on whatever specifications you're using, now that's going to be an agency call to come up with what the appropriate specification is and the gradation ranges. And as I mentioned before, it may turn out that 9.5 millimeter mixes may be the best choice. But that would be if the contractor is designing the mix or the agency. Ideally, they should do 3 trial blends. In a perfect world, you do coarse, intermediate, and fine. I know when we did that for the Alabama DOT test sections on the test track, with the gradations of the materials that we had to use, we really couldn't, we basically could get one in the intermediate. It was very difficult to get one too fine, or if you coarsened up certain sieves on one end, it fell out at the bottom. So it is a little bit challenging. And then for each trial blend, we're going to determine something called the dry rotted voids in the coarse aggregate. And again, it's kind of a, part of it's a calculation and part of it is just, doing the dry rotted unit weight. So once we've got the blend, the different components of the material that we're going to use, for each trial gradation, we're going to compact a number of specimens at kind of a guesstimated binder content. Maybe it's in the 6.5% binder content range, depending on the aggregate. Compact at 50 gyrations with a super pave gyratory compactor. We would include some type of stabilizing fiber. And then once we get those compacted, we'll determine the bulk specific gravity of the compacted specimen. So obviously you can't do the normal SSD test because it's so porous. So you either have to use a core lock device or a dimensional analysis. I'm sure that you could probably use the paraffin coating or parafilm if those still exist, but most people either do it with the core lock or dimensional analysis. And then you take uncompacted mixture and determine the maximum specific gravity. I'm not going to, there's a lot of information here, and we're not going to get into it, how you determine stone-on-stone contact. But there's some calculations that are done to determine the voids in the coarse aggregate in a dry rotted condition, and also the voids in the coarse aggregate in the mixture. And so it's basically, you do these calculations, and if one is less than the other, it indicates that you've got good stone-on-stone contact. These are the calculations. And again, so all you're doing, and you could see some of the terms, like in the second equation, you see that GMB term, that's from the compacted specimen, and GCA is the, gravity of the coarse aggregate component. Some of the other terms, the little gamma W, that's the unit weight of water. Gamma with a subscript S is the dry rotted unit weight of the aggregate. So again, and you do these calculations, and if you find out that, hey, the VCA of the mix is less than the VCA in a dry rotted condition, then you're good to go. And then if you've tried 2 or 3 blends, you ideally would choose the blend that gave you the highest voids in those mixes. Now your next step is, we've got our blend, and we're going to try to focus on determining the optimum binder content. So we'll prepare samples at different binder contents. We're going to batch them up, mix them, and condition them. Now, typically in both AASHTO and ASTM, as well as the NAPA document, they're saying the conditioning should take 2 hours at the typical compaction temperature, which I think is based on AASHTO R30. And what we did is we focused more on, at first we looked at longer term aging, because what happens with absorptive materials, you end up losing a lot of that effective asphalt if you don't get it conditioned properly, particularly with an open graded mix like this. So we went with our R30 has that caveat that if you're going to do performance testing, it's 4 hours, I think, at the compaction temperature, but we standardized it at 275. So that was a key thing that we did, and that's why I've got it highlighted in red. So then we would compact, once we do that conditioning, we would compact 3 samples to 50 gyrations. We would determine the bulk specific gravity using the Corlock device, and then we'd run the Cantabro test, and we'll talk about that in just a minute. We'd also determine the maximum specific gravity, or the GMM, on one sample, and then we'll run a drain down test on one unconditioned sample to determine how much drain down do we have, or how much bleeding potential would we have with that particular mixture. So now when we actually select the design optimum binder content, there's going to be several things that we're going to look at. So the first thing is air voids. AASHTO has a recommendation, that's PP 77, 18 to 22%. ASTM, they have a minimum of 18%. The NCHRP project 1-55 that I discussed, they were 15 to 20%. And again, what we standardized it at was 15 to 20% with the Corlock. The 1-55 project, that gives you the option to do it either with the Corlock or dimensional analysis. And dimensional analysis will typically give you higher air voids. So if you measured 15% air voids with the Corlock, you would probably get 17% with the dimensional analysis. So you look at air voids. The second thing we're going to look at is Cantabro loss. Again, AASHTO has 15% maximum loss on an unaged specimen. ASTM has 20% maximum unaged, 30% if it's aged, and I think these are averages, and I think they also include an individual value can't be over 50 or something like that. The NCHRP project recommended a 20% max for an unaged condition, and then what we worked on and did for the section that we did at the test track, we used a maximum loss of 20%, and that's after it's been aged 4 hours at 275 degrees. So, okay, and this is the Cantabro test. If you're not familiar with it, it's basically you compact a gyratory specimen, you put it in an LA abrasion machine, and you tumble it for a certain period of time. You know the mass of it, the sample on the left to start with, and then basically you take the biggest piece that's left, because you can imagine what it's going to look inside that drum. It's going to be all broken up into a bunch of pieces. Take the biggest, the largest piece, get the mass of that. You can determine the loss based on the before and after weights. So, and then the next thing you're going to do is you're going to select the optimum. You'll look at drain down to make sure that you don't have more than 0.3%, which typically when you're using fibers is not a problem. And then some agencies like to require a permeability requirement. AASHTO or ASTM, they recommended 100 meters per day. The NCHRP project kind of felt that 50 meters would be a better option. And I want to kind of share that with you for just 1 second. I may not be able to, if you can, hopefully you can see my mouse on the screen. But for example, if you were to set a minimum of 100 meters per day at a minimum permeability, it's kind of forcing you to have higher design air voids. They had a good relationship between this. Unfortunately, as you get higher up on the air voids, you start seeing an increase in the durability of the mixture. So some of these were poor performing pavements, whereas these were a little bit better. So anyway, NCHRP recommended 1-55, which is what we would agree with as well. So the last thing is using AASHTO T283 to evaluate moisture susceptibility. You can see the different criteria down at the bottom. Minimum TSR for AASHTO is 0.7. ASTM has a minimum of 0.8. The NCHRP project had a minimum of 0.7, but also a minimum condition tensile strength of 50 PSI. So that's kind of a newer thing on moisture susceptibility. And that is all that I have on this. So Buzz, if you're still with us, Buzz, I'm going to stop sharing and let you take over.
Thanks, Jim. Can y'all hear me okay? I hope so.
We got you loud and clear, Buzz. We got you.
Excellent, excellent. So Jim and I actually had a great time working together to build this high performance OGFC section on the test track last summer, and a lot of that involved the work that he did in the laboratory. Worked very closely with the NCAT laboratory to take some materials that do have some kind of challenging absorption characteristics and come up with a design that we felt like was going to do really well on the track when we installed it last summer. So I want to jump out of the laboratory into some construction suggestions. Take just a few minutes talking about that. We're doing really well on time today, so I'm going to slow things down just a little bit. But one of the things on construction, and these are kind of random thoughts on what things can we do to get better performance out of our open grade friction course mixes. And one of the things that I think we can think about doing is incentivizing using non-detrimental cleanup and clean out practices. And really what I mean by that is think about maybe working on your QPL, your qualified products list, and come up with some products that contractors can use at the end of the day or at the end of the paving run, if it's a night paving job, to clean all the equipment out, to clean everything up and to get reset and ready for the next day, and use some products that don't have any kind of a cutback or stripping effect on the mix. And there are some good release agent products out there. Some of those products we use in the beds of our trucks. And I guess what I'm suggesting is that we use those same classes of products to clean our equipment up on the road to get ready for the next day. This is kind of the basics, but we can preheat the screed to prevent dragging and scarring. One of the area where OGFC mixes tend to begin to fail first is at transverse joints where we pull off on new runs. So anything you can do to provide a really nice looking uniform mat when the screed pulls off, you're going to be better off, and you're going to get better performance. And preheating the screed can help. And this is something that we're a big advocate of, because we struggle with these types of issues at the track. You got a lot of cold iron, and so we do everything that we can do to preheat trucks and preheat the shuttle buggy and preheat the paver just as much as we can. And I think that that's one of the reasons why we have performance. One of the contributing factors to performance problems at transverse joints is because we can have relatively cool mix that we're placing out there. And so if you consider hauling hot aggregate that you're wasting at the plant, or using that maybe to preheat your trucks, or maybe even preheat your transfer device, and just discharging that material, that uncoated material, off on the shoulder. But you can also consider wasting your first load of mix at the job site, and you got to be prepared for that. You got to have a specification in place for that, and you got to have payment in place for that. But if you'll run that first load through everything, through the shuttle buggy and through the paver, discharge it on the side of the road, you got to have equipment to pick it back up and haul it off. But you can use that to heat up and to, quote, butter the equipment. And if you do have some cleanup residue on the equipment from the previous day's run or the previous night's run, then that mix that you run through can kind of clean that up a little bit before you start putting paving mix in it. One of the other things that you can do that's really easy is reorder trucks, and maybe take truck number 3 and put it in front of truck number 1 and truck number 2, because the mix temperature is going to be much more stable at the plant in that third load than it is typically in that first and that second load. Now, that in that scenario, you're not wasting any mix. If you want to consider that previous suggestion there and say, well, maybe we should waste our first load and run it through everything, then you got to have a specification framework in place to support that. The contractor either needs to bid the job knowing that they're going to have more waste than they typically have, or you got to be willing to ticket that load and pay for that load and compensate them for that load. And that's what I would advocate doing. Just having have it set up in the specifications that there's going to be so many tons at the beginning of the run that you're not going to put on the road. And you might even combine those last two suggestions and still pay for a wasted load. This is something that is really kind of basic paving practices, but I think it's super important for OGFCs because it is an open mix. It's a relatively thin mix, and it has a lot of air in it when it's hauled and when it's placed on the roadway. So you lose a lot of temperature in it, and we tend to not think much about mix that we spill or drop out in front of the paver. That can be from transferring into the shuttle buggy, or just kind of material that falls over the edge of the hopper insert or whatever. But we need to pick that mix up. We need to do what we can to keep that mix from getting on the roadway. But if you drop mix in front of the paver, that mix is going to cool down very, very quickly. And then the mix that you place over it is going to have to heat it back up again. And you're going to have if you look at that with an infrared camera, you're going to have a cold spot right there. And that is going to be a place where you can potentially have some performance issues down the road. So that kind of attention to detail, that you might think, well, that sounds extreme, but that kind of attention to detail can really have a positive effect on the performance of that mix out into the future. Many times on our paving crews, we think, hey, we got the crew out there, people need to be doing something, so we just kind of instinctively jump in and we do a lot of hand work. But especially with OGFC, especially when you're pulling off that transverse joint, when you're starting that run, it's better to not do any if you can help it. So you do hand work, you're going to end up with some cold spots, and that material is going to be more prone potentially to raveling out in the short life of the mix, and then contributing to a really serious performance problem. So try to minimize the hand work, not just at startup, but all the way down the paving run that you're making. Also, it helps to not let the hopper run completely down. And the reason for that, is because you're going to have more temperature loss when you have a smaller mixed mass in the hopper. And again, this stuff is kind of a heat sink. It's open graded, so it's going to radiate heat at a pretty rapid rate. It's going to give up energy more aggressively than a dense graded mix is going to give up energy. So don't let the hopper run empty. Don't let it run down. Try to keep a good steady flow of material coming through it. And most of these jobs, we're going to be using a material transfer device like a shuttle buggy, and that should help us to maintain that mass of material in the hopper insert or in the hopper. And then finally, this is really important, it's a big deal because sometimes our field crews, they kind of get a little carried away and they think, well, we're going to do our jobs well. We're really going to roll this surface and make sure that we got it good and stable on the roadway. But you need to roll for durability and not for density. And that's something that on the material side and the engineering side and the kind of the planning side, we know that, but you got to communicate that to the field crews. All you want to do, if this is a good, stable, healthy mix, is the word I like to use is seat. You just want to seat it on the roadway. When you over compact it, you're gonna crush rock, you're gonna collapse the voids, and then that mix is gonna be damaged. So we're spending a premium for a mix that's going to improve safety on the roadway. This mix absolutely improves safety on the roadway. There's no ambiguity about that. So we need to make sure that we can keep performance long enough where we can afford to use it, because it does save lives. And so we have to go to kind of rethink our design process the way Jim talked about in his part of the presentation, and then we need to step back and do the little things on construction that are going to help us to get more years out of these mixes, because we find ourselves sometimes where we have to say, well, we've got to stop using OGFCs while we figure out what we need to do to beef things up a little bit. And OGFC mixes save lives. Reducing road spray saves lives. So we need to make sure that we take the necessary steps to continue to use them. So Jim is the PI on this test section. He alluded to it in his part of the presentation, but section E9, I said 2024 track. It's a 2021 track. So that's my mistake there, Jim. Sorry about that. It is the current section E9 on the 2021 NCAP pavement test track, and E9 is shorthand for us for section number 9 in the east curve. So the way the track is laid out, if you think about that aerial that I showed you earlier, the tangents are oriented almost perfectly due east and west. So we have the north and the south tangents and the east and the west curves. So if you have the opportunity to visit the track, section E9 is actually the last section in the east curve right before the on ramp ties into the north tangent. So when our trucks pull off the track or pull onto the track, that's where they pull onto the track. It's kind of at the end of this section E9 or the beginning of section N1, the first section in the north tangent. So what you see on the left is the performance, or is the construction report on the left for section E9, and what you see on the right is the performance report for section E9. And I'm going to talk about this a little bit. Jim, you might want to unmute yourself to jump in here since we have some time to work with and talk about this just a little bit, because if you look at the construction report, it has the design, which I show is the target on the construction report. And in the case of this mix, the target was 3.7% minus 200. When we ran it, it was 4.4. If you look at the gradation curve at the bottom of that page, it ran just slightly finer than it was designed, but it still ran really well. It was a really good mix. This was a mix that, if it was subjected to the kind of the standard oil-based design procedure, it would have come up with an optimum asphalt content in the low 6s, which is kind of a typical historical value. This design actually came out at 7, and when we ran it with the plant setting on 7 and tested in the lab, we actually got closer to 7.2. So this had a lot of asphalt in it, and it ended up, what we ran had almost 1% more liquid in it than, certainly 3/4 to 1% more liquid in it than what the oil-based design procedure would show for this mix. But it was a 4-bin mix, and that's another important thing to point out about this mix. Is I'm a big advocate of don't do 2 stockpile designs, don't do 2-bin designs, have more material in the mix so that you have enough flexibility that you can tweak the gradation and stay on target. Jim, do you want to say anything about this before before I move to the.
Probably the only thing is this mix consisted of, I think two of the components were sandstone, which had a specific gravity around, I think it was 2.6, 2.7. And then it had, not blast furnace slag, but it had steel slag made up about 20% of it. And the steel slag had a pretty big increase in specific gravity. It was over 3. So again, Buzz kind of left out the part that it took us a while to get the mix dialed in properly. It was pretty challenging because I think in Alabama, this is some of a problematic mix at times. So, but yeah, I think we did a good job getting it down, and I was really surprised that it held the asphalt as well as it did.
Well, thanks for adding that, Jim. And sandstone and slag is again, you want a mix that's going to provide good friction. So microtexture is important, and angularity, crush faces, microtexture. So sandstone and slag are great materials from that perspective, but they can tend to be absorptive and challenging to work with. You can get some breakdown in the plant, and Jim was kind of being kind. Yeah, we did work really closely together, work really hard to dial this in with East Alabama Paving, with our contractor that we built the track with every year since 2003 here. So we all work really hard with our stockpile practices and with our plant adjustments to try to make this mix ideal. And I think in the end, we were really happy with what we got, but it was a challenge to get it down. I said we were happy with what we got. Well, now on the track, we're at about 3 million equivalent single axle loadings. We do 10 million equivalent single axle loadings in a 3-year research cycle. That's about 6 million heavy axle passes. So the page on the right that you see there is the performance report, and that report is really generated so that the section sponsors can pull it up on the internet whenever they want to and print it out and kind of have something for their records or have something to use in presentations. So it's the font and everything is not really good for presentations, but what I want to point out on here is the top graph there. There is 0 cracking in this test section. There's 0 rutting in this test section. And when you see flat lines of data, that means nothing is changing, and that typically is a really good sign. In that first plot, the cracking plot, that red line is the 20% cracking line, because that's a MAP 21 threshold. That kind of is a dividing line typically between a fair performing pavement and a poor performing pavement. So that there's 0 cracking in that section, and the rutting numbers are very, very flat. 2.5 millimeters of quote rutting means there's absolutely no movement in that mix whatsoever on the track, which is a very good sign. The roughness numbers are flat. The section is very smooth, especially because it's in super elevation coming out of the east curve. So the fact that the roughness numbers are flat is very good. And to me, this is the most important number for this section in terms of what do we have out there. And that last plot is macro texture in millimeters. And the big takeaway from that is that number is not changing. The data is flat. It's extremely flat. That means we're not losing any particles. When we begin to have particles come out of the surface of that mix, the macro texture will tend to drift up. And the fact that data is flat is a very good sign for this mix. So I went out there this morning and took a picture of this test section to put in here, because I wanted to really stress to everybody that this is a nice looking test section. There's not really any areas in the mat that appear to be defective in any way. There's not an excessive amount of color change between the wheel pass and then between the wheel pass. And when you get on your hands and knees, I think what you see is a really good stable aggregate structure. And I wanted to point out to the attendees, if you want to pull up these performance reports and take a closer look at any of this stuff for section E9 or for anything else on the track for that matter, pavetrack.com is the project website, and it's cross-linked between ncat.us, so you can get there from either URL. And if it asks you for a username and a password, the username is Asphalt Research, and the password is 2018 track with a capital T. So we don't, we try to not restrict access to the site. If you want to pull up these reports, look at these test sections or look at any other test sections on the track, that is the link that you will use for that. So we got 15 minutes to go before we hopefully can get into some questions. But I wanted to end up with some takeaways. I always like to have takeaways at the end of these webinars. As practitioners, what can y'all take from this and consider implementing in your practice, implementing in your specifications? When you do these surfaces, you need durable aggregate with good microtexture, and microtexture is the grittiness that you feel in your fingers. Microtexture comes from the quarry. I like to say microtexture comes from the quarry, macrotexture comes from the asphalt plant, and then roughness comes from the paver. But they're all kind of a wavelength analysis of the mixes. So the really short wavelength analysis is the grittiness of the aggregate, and you need good durable aggregate that's not gonna fall apart completely when you run it through the plant, and it is good and gritty, and that's going to give you good friction with these mixes, because that safety is the primary reason why we use these. I mentioned this earlier. Have a sufficient number of bins or stockpiles in the mix so that you can make some adjustments on the fly. I've actually seen projects where they were one stockpile designs, and when you have a one stockpile design, that might look okay on paper, but then you're at the mercy of whatever the quarry is selling you, and their production band is going to potentially be very problematic for you, because they can drift that band back and forth based on where they are in the deposit or what crushing processes that they're using, and you're completely at their mercy. So the more bins you have, the better off you are. I really like the idea of having 4 bins, but I like to have at least 3 bins when you put these together. As Jim said, typically these mixes are a 1/2 inch in mass. That's 3/4 inch if for states that specify mixes by maximum aggregate size, like Alabama. And in the typical range is 10 to 25% passing the number 4, and then 2 to 5% dust. Now, one of the challenges that we have with these mixes is if you design an OGFC on the fine side of that range, and then you have a little bit of breakdown in the drum, then you might be okay for design, but you'd be way fine during production, and then you're going to potentially have problems with a mix closing up on you and not being as permeable as you want it to be. So if you're someone who puts these designs together, look at the history that you have with the aggregates, and if you know you're going to have some breakdown, don't design on the fine side of that range. Try to stay in a place where you're going to be able to produce in a really healthy spot in terms of what does that stone skeleton look like. Same thing's true with the dust. If you have less durable aggregate, you're going to end up with more dust, and that's going to close the mix up. Now, these numbers, as Jim said, these are applicable for the 1/2 inch in mass mixes, but we've done smaller mixes. We did a 3/8 inch in mass mix on the 2012 track, and it did have, you look at that mix and you think, well, there's no way that mix is more permeable than a 1/2 inch mix, but it is more permeable, at least in our case it was. And not only was the initial permeability better, but the long-term permeability was better, because the smaller OGFC tends to be self-filtering, so it keeps debris from getting into the mix and clogging up the void structure and closing it down. Because these mixes, like when you put an OGFC down, and you might put it down, design it right and pave it right and have just a super good permeability, but over time the permeability goes down because the mix kind of seats a little bit, and then it gets filled up with sand and rubber particles and some other things. So the permeability tends to go down over time. And here on the test track with our trucks and with our loading, the typical OGFC after 2 years of our fleet operations, we've got about 20% of the permeability that we started out with, but we still have great spray reduction. So you're going to lose a lot of permeability, but safety is still going to be greatly improved on the roadway. So that's a good reason to look at those smaller mixes, because you do have better sustained permeability over time. And it might even, looking at design, maybe you even got some better quarry options for putting that mix together. So as Jim said, just to kind of really high altitude review that, you got to do the dry rotted unit weight. You got to age the samples. You use a gyratory compactor to put samples together, measure the loss in an LA abrasion machine. That's called Cantabro loss, and then run moisture susceptibility testing on the mix to make sure you're not going to have a stripping problem. And the good news is this is all stuff that a contractor can do on the front end of the bid. So there's not a mystery about what your binder content is going to be. So like if you bid it, if you're in a state where the agency does not pay for asphalt separately as a separate pay item, and you do your mix design and you think you're going to have a 6% asphalt mix, and then now it's a 7% asphalt mix, that's a catastrophe financially. So you're not going into that blind. You can do all this in a contractor's lab because it's a very simple process. Jim said, he mentioned air voids typically from 15 to 20%. We've done mixes on the track as high as 25%, because some agencies have a higher range like that. But as I mentioned, it does close up with time and traffic. We talk about balanced mix design for dense grade mixes, but I think this is a type of balanced mix design, because you really want to balance durability, long-term durability with short-term drain down, and then the flushing and the bleeding problems that you can have as well. So, the optimum binder content is in that range. So really, I consider this a type of a balanced mix design. Jim, if you want to jump in here and add anything, please do. This is very informal. You good with me? Continuing?
Yeah, so far so good.
All right, good deal. So when you put this mix on the road, you don't really want to compact it. You really want to seat it on the roadway without crushing any rot and collapsing any voids. One of our challenges is we're placing this mix. This is a mix that we typically use on interstates, on high-speed roadways. We're doing more and more of that work at night. So, there's less that you can see at night. You're more concerned about traffic hazards and things like that on these busy roads. So we really have got to make sure that we're not over compacting these mixes, because I think that has been a challenge with some agencies. Consider doing some of this proactive stuff. Some of it you can do in your specifications, and some of it is just some practices that you can promote in the field. But warm mix asphalt you can reduce the temperature of the mix and reduce the absorption of the binder as a result of production through those reduced temperatures. Have higher effective binder contents. That's a good thing for mix health. You can waste mix, you can reorder your trucks, a lot of that stuff that I mentioned earlier. And if you do all this stuff, our mission of safe and sustainable asphalt pavement at the lowest possible life cycle cost, that's attainable. We can do that. I think we can design and we can build these mixes so that when we have that really bad winter event in the South that happens maybe every 5 years, our roads don't turn into black gravel, and then we kind of step back and say, well, can we afford to use these things? I think there are changes that we can make in design and construction that can help us to get these mixes to last as long as we really need them to. So that was.
I'd like to add one thing to that previous slide, and I think it kind of encompasses a number of those bullet points. Is that I think we've all been around open graded mixes enough to know, like, sometimes you have a project where the whole project fails, and sometimes that happens at year 8, sometimes it's year 14, but it's basically given up the ghost, and the whole, and that's going to be related to the mix design. That's related to how much binder did you get in the mix. That's primarily going to be a mix design issue. But I know from my experiences with FDOT, we would have a lot of projects that, maybe 4 or 5, 6 years into it, you'd have isolated areas with raveling. And I really think it gets back to, having the mix temperature. And Buzz, the thing you pointed out about transverse joints, it was something I remember Buzz I don't know, about a year or so ago, pointed that out to me. And you start driving through projects and you realize there's a transverse joint, and then you got raveling for about 100 feet and it goes away. And then next time you hit a transverse joint, the same thing. And I know, again, from Florida projects, if a truck, they're paving at night, and a truck gets held up and it gets delayed, maybe the paver cools down. Maybe the mix has got cold clumps in it, but low mix temperature is a killer for open graded mixes, particularly when you're paving. The other thing I wanted to point out, I know there have been some studies with respect to the amount of dust or minus 200% minus 200 material in the mix design. I know when we designed these mixes, I didn't mention this, but we tried to get at least 3% minus 200 in the mix. That again, you can, everything, it's a balance, but you don't want to go too low on that dust. You don't want to go too high either, but you want to at least get it off the bottom. So probably at least get it up to like 3% when you're designing the mix.
Those are all great points, Jim. And that the issue of poor performance off those transverse joints, we've talked to agencies where they've said, oh, well, we don't want to, that's going to be expensive if we waste that first load, or if we, make an investment in mix there at the beginning of that run to try to prevent that. Well, what's the maintenance cost to not doing that? It's astronomical. So, it might be that, I would encourage the agency to step back from that and think of it holistically over the life cycle of the pavement. Do you need to make a change like that, where you're paying just a little bit more on construction because you're saving a ton of money in maintenance work and performance age over the life cycle of that pavement? So there's our email addresses, and Travis, I'm gonna hand back off to you. Do you want me just to advance slides, or you?
Yeah, if you'll keep that, that'd be great. We got 5 questions that have come in. Let's see if we can get a couple of those real quick, and then we'll do our end slides, and then we'll finish the questions. But what paver was used, and what type of tack, and how thick did this test section go down that we've been talking about today?
Jim, you want to handle that?
I don't know the paver, and I forget what tack.
It was a Rotec. It was a Rotec. I filmed
okay.
up.
And Buzz, what was the tack? Was it a Trappist product, or was it an SS1H or something like that? I don't remember that.
For this, and I'm back on the construction page, and if you look on the left hand side near the kind of the right side of this left document, the product that we used was called ETAC HD, and the rate on that looks like a 0.15. And so this is the kind of stuff you can get off of these construction reports. If you have some curiosities like that about the work. It was placed with the Vogley paver. We did have we kind of interchanged a Rotec paver and a Vogley paver in the last summer's track build.
Okay.
But you can get all that off of this construction report.
Okay, great. So if we're going to use a ground tire rubber type of binder, would you put an extra gap in an OGFC, or would you design it any differently? Jim,
you want to take that?
Yeah, my 2 cents would be no. I don't think. I think you've got enough openness in that gradation that you wouldn't need it. If it's dense graded mix, I think you would, but I don't believe you'd need to change or make the mix more open to account for that, unless you're using abnormally large rubber particles.
okay, great. So on
we use like a -40 mesh rubber in 2012 when we used recycled tire rubber, and we didn't make any changes to the. You can kind of make the argument, hey, it's a black sand that we need to account for, but we didn't change it in any way in that case.
Okay, great. I want to get to the rest of these questions, but I want to make sure we get to those slides that we can cover before the top of the hour, so people can go if they need to. Buzz, will you advance? Probably hit 2. Always want to throw training in your pocket out there. Search it on YouTube. There's always some great training on there. Give it a look. Advance it, please. Again there, Buzz. I want to give a shout out for next month on October 20th, the same time. It'll be at 10 a.m. Central. We're going to discuss 3/4 inch thick, nominal maximum aggregate size of 4.75 SMAs that are being used for high performance preservation type of work. So you can click that link there, or hit that QR code. The registration's already up for next month. You can see what's going on there. So I want to thank those of you that need to go, and then if you want to stay, we're going to answer a few more of these questions before we shut it down. So the next question came in from Alan, and so what PG grade of binder do you think is preferred for these OGFCs?
You want to handle that, Jim?
Yeah, I'll give it it'd be interesting to hear your opinion too, but I certainly think that it ought to be something like a polymer modified, something along the lines of a PG 76 - 22. I just think it helps when you're with the durability issue.
I agree with that. If you're going to use ground tire rubber in the design, it might be that you can go with a 67 22, but we've had good success with polymer modified 76 22 here at the track.
And I just want to point out for those of you that are not from the southeast part of the U.S. that PG 76 - 22 is a half-step grade that is available in the Alabama region. So the next question that came in is what are the recommendations for or recommended measures for declogging the mixes during their service life? Anything we can do? I know vac trucks have been some things that have been used in the region.
Well, that's something that I think it's Japan. They have there's specialty equipment that you can use to vacuum out or jet out OGFCs. The challenge that we have is that those trucks they move very slowly, with respect to traffic, and we're using OGFCs in typically in high speed, high traffic locations. So that's tough to implement. There is some really good tech out there, but I think each agency would just need to make a decision about that, based on their needs and their safety concerns for their particular projects.
Okay, great. So are there any recommendations on like the coarse aggregate before we do the mix design for the LA abrasion loss that would help make these more durable? Do we increase that, or would we want to leave it the same?
You want to handle that, Jim?
Well, I'm not really sure. I think it's gonna, like all good asphalt answers, it's gonna start with it depends. If you have a problem with aggregate, that breaks down during production or if you're seeing that your rock is breaking down during the compaction process, you certainly want to make sure your rollers aren't too big or you're over rolling it. But if it's like the first coverage with the roller and it's a 12-ton roller, holy cow, you may want to consider changing some of your maximum LA abrasion values. But I don't know if there's any one value. For example, in Florida, there's certain limestone sources that may have LA abrasion values that are higher than most other states, but don't have problems with that type of that issue. I don't know, Buzz, what are your thoughts?
Well, we did an SMA mix in 2003, and I saw some people in the participant list that were involved in that and have some direct knowledge of that. But when we tested LA abrasion for the stockpile that we hauled here, we measured a 63. So this was really soft rock, and the aggregate control program number from this state was quite a bit lower than that, but it was very high LA abrasion loss material. And we were able to run it as an SMA, and it worked, but it had a lot of breakdown. And it was like the more you tried to fix the mix, the more you messed it up because of the amount of breakdown that was occurring. But it made a good mix, and it was good and stable on the roadway. I would just echo Jim's thoughts. Just make sure you can produce it. What's coming out of the plant is going to be that permeable gradation that you're looking for. And when you put it down, make sure that it's a good enough rock that you're not going to white top it and crush it and expose uncoated aggregate that you don't really intend to do.
Okay, great. I like Cliff's Silking House's comments here. Avoid paver stops. We teach that everywhere we go for every kind of avoid paver stops. Do what you can to avoid those stops. But he also says that there's really a fine line between seeding the mix and enough compaction to keep it bonded properly. So there's some experience from the things that Cliff has done there in South Carolina. So the next one is what's the recommended method to introduce fiber into the mixed design sample? So in the laboratory, what's the best way to mix it in there?
Jim, you want to handle that?
Well, I think very carefully is a good start. No,
Yeah.
actually, we're doing some work with FDOT right now on open graded mixes, and they have their own particular way. I don't know. I didn't do that part in the lab, so I don't know how they add it in the NCAT lab.
Okay. What are the recommended permeability values for the horizontal and vertical permeability there?
Well, the values that I showed in the presentation, that was, let me make sure I'm giving you the right numbers, where AASHTO is recommended 100 meters per day, and the NCHRP project recommended 50 meters per day. I think that was vertical permeability through like a laboratory permeameter on compacted mix. And I'm not sure what the horizontal, I can tell you that looking at some of the data from the ALDOT project that we had on day one, before they started loading it, the permeability, and I'm gonna switch units on you, but it was about 38,000 times 10 to the minus fifth centimeters per second. So again, I apologize from going meters today to centimeters per second, and I can't convert that in my head. So again, I don't have that number off the top of my head. I can tell you that we were between 35 and 40,000 times 10 to the minus fifth centimeters per second on day one with construction. And it's dropped down to, it's lower than 20,000 now, just due to traffic.
That's kind of a typical number, Jim, on the track. We've had mixes that have been as high as 60 or I think 70,000 on that scale, and then we've had mixes as low as probably 25 or 30,000 at the time of construction. And then you got to know those numbers are going to fall over time. And on the track, because we do quarterly permeability testing in a way that you can't really do on open roads, and you see a very, very predictable decline in permeability for all different types of sections.
Okay, great. So I like this question. I think it's a great one to get in here. For use in urban areas, what kind of information is there regarding noise issues using open graded mixes?
We did a great study for Georgia back, I think it was on the 06 track, where we did a smaller permeable mix over a larger permeable mix, and this is a poor attempt at an acoustic explanation, but it kind of makes a fish trap for noise attenuation. That was the quietest, as far as I can recall, that was the quietest section we've ever built on the track. So like what you see is the smaller en masse mixes are quieter mixes, and when you can place them in multiple layers like that, if you can find a way to do that, you can make a super quiet mix. And we had really good construction and performance experience with that back in 2006.
Okay, great. So regarding the section that we've been talking about that's on the current track there, do you guys remember what the weight of the rollers were, the number, and maybe even the number of passes that were used in order to get that seated correctly?
I should have been prepared to answer that question, but I'm not. If whoever had that question, if you want to shoot me an email, I can research that for you. And we've even, we videotape, we actually video record. I got to get in the right decade, Travis. We video record every test section as it's built, and so I can share that with someone who might really be interested in it, so you can see what the roller was and what pattern we used.
Yeah, there you go. And then there was a question in here that came about that, wondering if they had missed recommendations for the LA abrasion loss, but I don't think we put that in there. There was the Cantabro, and so I think it was what, 20% for an unaged and 30% for an aged. But
no,
then,
Travis, I think it's TP 108, which is Cantabro.
Okay.
So yeah, so you're right. It's 20% loss aged maximum 20%.
You see numbers typically LA abrasion for aggregates that are like 30% or 25 or 30% loss is kind of a typical number that for a high quality aggregate. But again, if we've made it work much higher than that. So it just depends on where you want to set your specification threshold to know that you're going to get good performance.
Yeah, the one thing with Cantabro is it kind of drives the binder content higher. And so with the 4-hour aging that we have at 275 and a 20% max, it's going to require a higher binder content in the mixes to meet. And that's where, fibers and everything else come in. If you have you want to make sure that you don't have with that higher binder content, you don't start getting drain down. So that's why there's a drain down test in there as well. Plus we're also measuring voids. So they all kind of fit together that hopefully will give you a good durable mix. There's a question, Travis, that had just come up, which I don't think I have an answer to, was regarding, is there a test that you can run in the lab that can determine what the decrease in permeability will be? And I'm not familiar with anything. Buzz, are you or Travis?
I am not familiar with a test that you can run in a lab. Like I said, I can tell you that we have observed a very predictable change. So there's some data that we can share. Jim, you and I probably need to get together and work on publishing some of that on the NCAT website to get that into practitioners' hands, because you saw all the OGFCs that we've done on the track. We've got a really good library of permeability testing for those mixes. But because it is very predictable, at least for the same end mass, I don't know that we really need a test in the lab to see how that's going to work. But that's an interesting idea.
Sounds like a great research project.
Yeah, I think we've got some good data that we can mine and come up with some guidelines based on the end mass and the and the percent passing the number four sieve. But yeah, it might be a good research project.
And so one last question here, and then we need to shut this down because we're quite a bit over. But and I'm not sure I totally understand what was being asked here, but it says, do you use the same design method for the ultra thin friction cores of say 12 millimeter thickness with a smaller end mass? And that's about a 1/2 inch thick. So I mean, that's a pretty thin mix.
If it's a permeable mix, I think you're going to use the same, the same design concept, and states can get pretty thin on the OGFCs. You lose flow capacity when you go thinner on OGFCs. So you lose the ability to remove water in heavy persistent rain, when you go thinner, because the flow capacity is reduced. But if it's a permeable mix, I think you'd have the same process. Now there are some mixes out there that are gap graded mixes, but they're not designed for permeability. They sort of live in between an SMA and an OGFC.
Yeah. And
there's a different design process for those.
Okay.
Buzz, I'm dating myself with this, but back in the day when I first started with FDOT in the 80s, Florida used, it was a 3/8 inch nominal maximum aggregate size, and it was specified at a minimum spread rate of 40 pounds per square yard. So it was barely 3/8 of an inch thick. I mean, it was, about as thin as you could go with the aggregate that they were using, without starting to crush the rock. So there was nothing, I mean, Florida just used the standard. So I don't think you'd have a real, you could probably even use a 9.5 millimeter mix, provided that it was on the finer side. So I don't think there'd be any significant differences unless you went down maybe to 4.75 millimeter. I've never heard of a 4.75 millimeter open graded friction course, so I don't know if you all have.
So I'll ask you a question, Jim. Why did FDOT get away from that mix? Was there a performance issue why they stopped doing that?
Yeah. It was really, one, you had a lot of construction issues. It was so thin, it contributed to the raveling. So eventually they went where it was, they tried to get it up to a 1/2 inch thickness. And then we ultimately, Florida copied the Georgia DOTs. They had a demodified open graded mix, and which was a 3/4 inch nominal maximum aggregate size. And then they, changed half inch nominal maximum aggregate size. And then, started putting it down thickness. So
when we did the 3/8 mix in mass for Alabama in 2012, we placed it at 3/4 of an inch, and so that the permeability success that we saw with that, and durability success that we saw with that, I think was partly because of how thick we placed it. It performed really well.
Okay, there's some really great discussion. A lot of folks have stayed, so I appreciate y'all that have stayed to the end. Again, I want to plug the next month's webinar. Please join us again. We have a lot of fun with this, and we hope that you guys are getting great information from it. And with that, for Buzz, for Jim, for everybody else here at NCAT, we'll see you next month.
Hey, everybody have a blessed day. We appreciate it.
Take care.